In this video, we look at using matrices to solve a system of equations. You may want to review Gaussian elimination, which was discussed in week 2. The idea. A matrix is an efficient way of representing a system of equations. One important application is to be able to represent such a system in a computer. The computer can be used to solve the system, such as given here. The augmented matrix is the matrix obtained by listing only the coefficients of the equations in table form. The following matrix is associated with the above system. Notice the rows correspond to the equations, so the first row is associated with the first equation. Second row, second equation. Third row, third equation. The left side columns correspond to the variables. So the first column is associated with the x, second column with y, third column with z. The rightmost column corresponds to the constants, as you can see here. When forming either the augmented matrix of a system, you should begin by vertically aligning the variables in the equations and using zeros for the coefficients of missing variables. That's what we did in the third equation. Notice the y is missing and we associated the 0 with that coefficient. Elementary row operations. Recall the 3 operations that can be used on a system of linear equations to produce an equivalent system. The following are equivalent operations that can be performed on an augmented matrix. First, you can interchange 2 rows. Second, you can multiply a row by a non-zero constant. Third, you can replace a row by adding a multiple of a row to another row. In matrix terminology, these 3 operations correspond to elementary row operations. The resulting augmented matrix is referred to as a row equivalent matrix. Gaussian elimination with back substitution. Row echelon form and reduced row echelon form. A matrix in row echelon form has the following properties. 1. Any rows consisting entirely of zeros occurs at the bottom of the matrix. 2. For each row that does not consist entirely of zeros, the first non-zero entry is a 1, called a leading 1. 3. For 2 successive non-zero rows, the leading one in the higher row is farther to the left than the leading one in the lower row. What that really is saying is you're forming this diagonal. A matrix in row echelon form is in reduced row echelon form when every column that has a leading 1 has zeros in every position above and below its leading 1. I'll now demonstrate how we can use the row operations to get the augmented matrix in reduced row echelon form to solve the system. Example, we'll now solve the following system using matrices and Gaussian elimination. Keep in mind there is no one distinct way of actually doing this. First, express the system as an augmented matrix. Pause the video. The augmented matrix is given here. Now, what we're going to try to do here is eliminate the x variable from the second 2 equations. We're going to do this by replacing row 2 by adding rows 1 and 2. We'll also replace row 3 by multiplying row 1 by a negative 2 and then adding to row 3. Pause the video. Here is the resulting matrix. Our example continued. We'll now seek out to eliminate the y variable from the first and third equation. We'll replace row 1 by multiplying row 2 by a -4 and then adding to row 1. We'll replace row 3 by multiplying row 2 by 8 and adding to row 3. Pause the video. Here is the resulting augmented matrix. Now, we're going to replace row 2 by multiplying row 2 by a -1, because again, we want the coefficients to be +1. The second thing we're going to do is replace row 3 by dividing row 3 by 6. Pause the video. Here's the resulting matrix. The example continued. What we'll do now is seek to eliminate the z variable from the first equation and the second equation. We do this by replacing row 1 by multiplying row 3 by 5 and then adding to row 1. Replacing row 2 by multiplying row 3 by 2 and then adding to row 2. Pause the video. Here is the resulting augmented matrix. Notice this is in reduced row echelon form. We have a diagonal of 1s, and then vertically notice that out the coefficients other than 1 are all zeros. We can now read off our answer. And that answer to the system is, pause the video, x is equal to 7, y is equal to 2, and z is equal to 2. Time for a quiz. Is the following matrix in reduced row echelon form? Pause the video. No. In row 2, column 3, the -2 here needs to be converted to a 0. Is the following matrix in reduced row echelon form? Pause the video. The answer here is no. Row 2 and 3 need to be interchanged. Remember, you're supposed to have a diagonal of 1s. So these two rows need to be interchanged. Determine the solution associated with the following matrix. Pause the video. The third equation is saying 0 is equal to 4. This system has no solution. Well, remember, when in doubt, reach out. Thank you.